Hello, my name is Bruno. I'm recently been hired by SoundCloud in Berlin to be the data warehouse solutions architect. So I've started this big challenge in last June. Also a very personal challenge because I've moved down from Lisbon, that is my hometown, to Berlin. So the move was great because I arrived in June. If I arrived, for example, in December, would not be such a good move. But basically my main role is to design, develop, and maintain the data warehouse infrastructure in SoundCloud. That is an infrastructure that started to be assembled basically when I arrived in June. Back in the past, and I will tell you a little bit of the history. There was not so much of that concept of data democratization or business intelligence or data warehouse in SoundCloud because the company didn't push much attention to it, and all the needs of analytics were basically pulling out the data from the systems, whatever, and spreading it to spreadsheets, and then the business analysts consult the data there. So we moved to an infrastructure that I'm going to try to describe here at much detail as I know and as we are now. But a little bit of SoundCloud for those who don't know too much about the company. So SoundCloud was founded in 2008 by two guys that were passionate by music and also technology. These two guys combined these two passions and started a company that basically its purpose is to share the sound, your private sounds, or if you are an artist or a speech or podcasts to the world. So basically, now 2013, SoundCloud is the world leading audio platform, a little bit different from other platforms like Spotify or Pandora that basically are focused on music. SoundCloud is more focused in sound, basically. It's like where we gather all the sounds that people record, like personal sounds or podcasts or even comic releases or something. So this has been a very fast move. So every minute creators in SoundCloud are uploading 12 hours of new and fresh sound. It's amazing because, for example, for people to hear each new sound that is created every minute. For example, it has to be 720 people to be listened every day, 24/7. So basically, it's an impressive amount of sound and, of course, of data. So SoundCloud for now is reaching more than 200 countries, and we reach over 200 million people every month. That is also impressive, and we are growing. Our target, a little bit ambitious in my opinion, but probably is going to happen, is that we want to reach 1 billion people, but let's see. So these 200 million people represents 8% of the internet. It's amazing. It's really amazing. Before I worked for SoundCloud, I didn't had this notion of how big the company is. I was a user, not a creator, but this 8% of the internet, it's a lot of big deal here. So this is the main aspect of our website. Here we can sign in for free and hear the world sounds without any limitation, like in comparison to other platforms that have some limitations of usage. If you are an artist, you can upload your sounds through a limit. Then we have 2 different subscriptions that creators can use to share their sounds to the world. And of course, this is the main vehicle to creators to upload their sounds. So it's the only platform that combines also the artists and personalities like President Obama is there to the big labels. Basically, it's the only platform that you can literally, and that is not just for selling the idea, but you can send a message to Snoop Lion and get one back. Basically, SoundCloud connects people, listeners, to the artist directly. And of course, there are some events that sometimes SoundCloud do in terms of meeting up the artists and the labels and the listeners. The most important one probably is the South by Southwest Festival in Texas that occurred every year. So this is a good example where we meet up all the artists and the labels. So SoundCloud is basically present in every major platform and integrated with the main social platforms like Twitter, Tumblr, Facebook. You can reach it on your Android and on your iOS phone. SoundCloud today released an integration with Instagram. It's really new. You can check it out. So moving so fast like we have did in the last 5 years puts ourselves also in danger because people that works at SoundCloud want, for example, to know a lot of things. What's happening to the data? Where are we going in the next year? What was the successful campaign? How many users did you get from this campaign, etc. So answering to all of these questions and having a very fast changing infrastructure was very difficult to us. So we start thinking about a set of goals or a set of principles that basically we call it at the beginning data democratization. That basically the principles are avoid silos. In the past, like I said before, teams were gathering their Excel spreadsheets or Google spreadsheets or their own MySQL databases with data that was provided by the platform, and then do some analysis and reports. We don't want this anymore because data is changing, and we want to get the accurate data to the business user, and not having like some small silos of information that is available for team A but not available for team B. So actually, another principle is to remove unnecessary restrictions. This comes also from the last principle. Basically, when a team has in its possession some Google spreadsheets, sometimes the results or the analysis that are made are not the same as the team B, because sometimes we get different conclusions from the data we are showing to the users. We wanted also to provide simple tools. That's a thing that we've been struggling in the last probably month or so. We wanted to provide a simple reporting tool that users can not only view the graph, the static graphs, but also to do some data exploration. That was a big issue because people that receive the data are not techno people. So we wanted to experience them like some easy way to look at the data and provide the accurate analysis. And the last principle is basically teach people how to use data. Sometimes it is a problem because people just I want the number of subscriptions yesterday from Brazil, but they get that number, but they don't know how to interpret that number. If it is a good thing, it's a trending thing, it's a thing that can be explained by the factor X or Y. So basically, we wanted also to teach people how to use data and to make the accurate analysis for their questions. So this is no rocket science. Basically, the main goal or the main principle of data democratization is deliver the right information to the right person at the right time. So this is how we have done things until last year. Basically, we had two main databases. This production DB is basically where we gathered listens, tracks, users, and this analytics DB, it's a database that was produced based on productions DB, but had more analytic data, like some dimensions built, some fact tables built in a strange way. And then what we do for analysis purpose was to load this data combined into Google spreadsheets and make it available to different teams. So imagine all of this data, and for example, in listens we have 100 million listens per day, more or less. Sounds, users' comments, all of this data gather in a MySQL database, and then doing some queries on this data through a MySQL database, and then deliver it to the end users. It was pretty much impossible, and it was an architecture that couldn't be alive for so long. Of course, there's, for example, in listens, we can analyze it by different ways. We have several dimensions to analyze a listen. We have the timestamp, where it started, when it ended, the duration, the sound, who is the owner of the track, the listener, and the location of the track. So basically, it's not only to have all of this gather in one place. It's just basically having this and then organize it by these different dimensions. So, and of course, there's also some additional metadata that the listen generates. For example, the location within the sound, where was it played, the context, and the segmentation of the user. More or less, a listen creates 6,000 events by second. So we are talking about big data. That's when we realized we had a problem, and we called Dupe to the rescue. Basically, we started our infrastructure with 2 data centers in Amsterdam. We have more than 200 nodes active this time. I think, more than 200. And in Dupe, we gather all this data. All data related to listens and to search, recommenders. So basically, some web analytics data we have there. And Dupe was helping us a lot because our MySQL databases were not dealing with the job. Dupe is good for storing data, but it's not the perfect solution for our data democratization principles, because the data is sealed in Dupe, is organized in buckets of information. There's no existing data governance that we can put on Dupe. There's some issues accessing data in Dupe. It's not like an SQL database where you connect and do your easy queries in a known technical user point of view, of course. It's not real time, and the access is slow. So we've studied the market and trying to find some solutions, and we did some benchmarks and proof of concept, and we started to work with Amazon Redshift. That basically is a very powerful server provided by Amazon, and is fully oriented to that warehouse projects. It's optimized in terms of space, in terms of data sets. We have currently more than 1 petabyte of data in total. So we don't have still everything in Redshift. We are importing the data, the past data into Redshift. It performs a fast query and I/O performance. So you can connect to Redshift via Postgres database, simple user password, and then provide your queries. And that also another feature from Redshift is that columnar storage technology that provides you one of the best performances. So changing from that past infrastructure to this new one, that is going to be a little bit more complex than two databases loading into a spreadsheet. We first identify our source systems. We have data in Hadoop, like I said. We still have some data, for example, the tracks data, user data are still stored in the MySQL database. And we have, of course, some external systems like our web analytics software, our financial software that we control our finances are in an external system. The first step is, sorry?
Did the data in Hadoop originally come from MySQL a long time ago? Did they take the data from MySQL and push it into Hadoop, or is it?
Yeah, some data, yeah. The listens data, for example, the recommender, all of the, we can call big data or big data size. We move it from the MySQL into Hadoop, yeah. So after we identify the source system, we load this data into the staging area in Redshift. I will explain how this data import is going to be made in the next slides. And then we have a typical star schema design model in our Redshift that is going to be loaded with the data that came from the staging area. So basically here we do some copy commands and map reduce jobs to store the data in this particular bucket that basically is plain tables without keys, without any kind of relationship. And then we have this kind of star schema model that we use to load our data cubes. And on top of that, we have the data exploration tool that basically is also a recent thing. We have done some experience with other vendors and other companies, but we recently choose to go with Tableau as our reporting system. Tableau is very good in terms of layout and how do users build their graphs. So we are not looking for a complete BI solution. We added before some also case studies from other companies that offered also a ETL tool, but we decided for Tableau basically for is easy way to access the data in terms of graphical interface and the analysis that could be made. So a little bit in detail, how do we import data from the source systems? First, we gather the data from the other several systems into Amazon S3. We have two types of imports. We have the full imports and the daily or incremental imports. So the daily or incremental imports are the ones that we use for big data, for listens, for recommenders, for affiliations, basically. We basically pick the data from Dupe, execute some map reduce jobs in order to transfer the data to Amazon S3, and we daily load the day before with this data. And we have the full imports that basically for tracks, users, and other data that we don't classify as big data. It's a fully dump of that tables into Redshift. I didn't talk before, but it was in the previous slide. We have an internal tool that we called Bibimbap. I will explain the name later why. But basically, this is our job scheduling tool. Okay, it's an internal tool developed by a couple of engineers, and we use it to schedule the jobs, to schedule dependencies, and all for and for the ETL as well. So the second step is to rebuild the staging areas for the tables that we are using full imports. And why we do that? We recreate basically all this schema every day in order to recreate the dist keys and the sort keys that Redshift uses for its internal performance. So we are basically using the Bibimbap software to gather some IML configuration files. That's where we store the data, the create table statements or the data structure, and then we basically every day the Bibimbap executes the create statements, and then we have a full control in changes in the data model. For example, if a new column appears, it automatically synchronizes with our tool Bibimbap, and then that column is created in the next import. So the third step is basically import from S3 to Redshift. Again, for the full imports, we do a truncated copy. For the daily imports, we just do a copy because it's an incremental import. And this data goes into the Amazon Redshift staging area. So one step forward, now talk about our ETL script. We divided into four different layers. The first layer is where we load the data from the staging area into our data warehouse star schema for the dimensions. Basically, we can have some kinds of static dimensions, but for example, for the tracks and the users, that the state of the user changes. For example, if he acquires a Pro plan 2 days ago, we have to have a different kind of dimension that is the slow change dimensions that basically tracks these changes in this example in the user state. So the second layer is where we load the data from the staging area into data warehouse, but this time the raw data from, for example, the listens, the plays, the impressions. So we have this layer that basically all the events that are generated, we pick them up in the staging area in Redshift and put it on our star schema. A third layer, more for aggregation purposes, we aggregate these fact row tables into tables that are structured for the most common analyses that are made. So basically, it's a layer where we aggregate data from the fact row tables. And the fourth layer that is not yet implemented or decided is where we provide Tableau with some scripts that goes into the data caching used for Tableau to generate the graphs. And we are going to do this basically based on disaggregated fact tables and produce some small data cubes for Tableau. Oh, yeah. So where does these layers fit in the big picture? So the layer 1 and 2 are basically here, and we do some operations in data cleaning and data transformation. The language we use is basically Ruby and SQL. The third layer, more data aggregation operations, and that loads our cubes. And the fourth layer is where we switch the data to Tableau for better performance and for data caching. So talking about some software that we use or solution that we use to to help us on this data democratization. We have Bibimbap, that is like I said before, a job schedule tool, internally developed. It's web-based, so it's not very pretty look from here, and not even looking from our web browser, but it works. Basically works, it gives you the light with the status of the job. We can set dependencies between jobs. We can make executions in multiple machines, so basically it's also combined for performance. And Bibimbap supports all of our ETL layers. Basically, what we end users have to do to schedule a job in Bibimbap, it's produce some JSON file with some characteristics. For example, what script it is going to be called, what kind of parameters do you want to call on that job, and then execute with, and also put the dependencies on, and then the job is executed in that time or after a job or whatever. So basically, it's a very simple tool, but very useful for our infrastructure. Yeah, the name comes from a very delicious Korean dish that people that develop it like it a lot. So basically, it's the origin of the name. Tableau, like I said before, it's a recent acquisition. We had some internal tools also developed, but we wanted more. We wanted a software that will simply and fast access to data. Very important, we wanted not only to users to analyze static data like we had before, we wanted users to go into data and basically drill down into some of analysis and making their own decisions. It's an individualized reporting, so basically users can define their own reports and assign the reports to someone to analyze inside of the team. Tableau also allows interactive between users. For example, it's a very good feature that I didn't know, but for example, a user can comment on these yellow lines and said what's happening to this and tag a person from our team, and we can basically respond and interactively inside the company speak about data and the status of the data. And another thing that helps us with our decision, it's fully integrated with Redshift. So this is basically our timeline. In the first stage, that is the analysis stage, we basically do some gap analysis between the business users, what do they have and what do they want to have in our data democratization infrastructure. We set up a list of requirements, basically with basic interviews from that users. With that, the consequence of that was we starting to make our information design, mapping the fields from our source system into our data warehouse. And after that, we have the design and build stage where we define the infrastructure. That's where we define that we are going to use Redshift, and the design of the data model. After that, we have the build stage. That's where we are currently in now. We are building the ETLs, the reports, and everything. So basically, it's I can say that we are more or less here. And we have the final stages, that is the test and deploy, that we interact with the end users and present the platform, do some workshops, and educate them how to use, in this case, Tableau as a reporting tool. So basically, the data democratization principles we are going to achieve when we have this whole platform set up. Reports can be designed by end users. Users are not dependent on us to give them the reports. So with Tableau, it's a very simple tool where you can design the reports. We now have a central repository for data analysis. No more about that Google spreadsheets. No more about unreachable MySQL databases that were owned by teams. We have user interaction. So here we teach and provide the users with the data, and we can interact with them, basically explaining why the listens were very low on the day before. So basically, it's a good thing that we want to add in our data democratization. Probably the most important one is data from one source only. So basically, all the data that we use for reporting purposes are stored in Redshift and no more of other different source. It's also a scalable solution. The way we build and design the data model and our ETLs, we are preparing it for future developments from SoundCloud. And basically, is the result of that is giving data to the people and for them to have their analysis and their conclusions. So these questions that I presented in the beginning, I cannot tell you that this is totally true, but we are going to answer them, if not now answered, but in the near future, with this when all this completely infrastructure is built. If you want to move to Berlin and be a part of our team, we are fully open to some of you, if you are interested, of course. And thank you again.